Oh, okay. So here we are. Hi everyone, welcome to the Load Festival. I am Luca Soato, and today we're going to talk about the Jupyter revolution for data engineering. So here's my friend Andre at the direction. So if you can help us with the slides, perfect. So here I am. I am Luca Soato, and I work as big data developer for Sorentech. We are the branch focused on data, analytics, and so on. So today we're going to introduce you briefly to the world of big data. Then we're going to talk about Jupyter, that is an interactive computing tool that is pretty popular among data scientists. And then how we managed to use it, but in a data engineering context. So let's begin with big data. So how we can define, what do we mean by big data? Often we can, well, when we refer to big data, we refer to the 3 V's. So volume, velocity, and variety. Volume, because you have tons of data. For example, you have terabytes, petabytes of data. Velocity, because you may need to compute that data with a very small latency. So you need a lot of compute power. Variety, because the data may come from many kinds of sources, maybe in a lot of different formats. And to solve all of these problems, often from an infrastructure point of view, it's easier with instead of scaling vertically, so with one big computer, but it's easier scaling horizontally, so with many computers together to form a cluster. And to manage that cluster, there is a collection of free open source software under the name of Hadoop. The Jupyter Project helps you managing a cluster of big data. So one of its main tool is HDFS. HDFS is a Hadoop distributed file system. So it is a block storage that acts like more like a file system. So you have this cluster of computers, and you have your files, your big files, split in many blocks and distributed and replicated across this cluster. So you already have an idea of reliability. In this way, if one computer goes down, probably many other computers in the same cluster has the same data, so you don't lose data when that computer goes down. And that's a nice advantage. But one of the disadvantages of this process is networking. Networking is fundamental in these clusters because instead of having one single place where there is all the data, they are distributed. So you need to communicate with one node and others. So we are saying how the storage is, how the data is stored, and how do we compute data? To compute data, we are using Spark. Apache Spark is another open source software that is extremely powerful. It is a distributed computing engine. So instead of solve by yourself of all of the problems introduced by the concept of this cluster of multiple computers, you can program directly, and Spark will adjust the query you make to all the computers. There are different modules in Spark. Spark SQL, for example, lets you use the structured query language across data on your server. Spark streaming is, for example, when you have to process stream of data and connect them, for example, to Apache Kafka. And Spark ML is for machine learning purposes. So And Spark is extremely versatile. You can connect it to a lot of different databases, MySQL, Postgres. You can use a different storage engine of Hadoop, for example, HDFS, HBase, Kudu. And as you can see here, there is the main advantage of using Hadoop. When you use a proprietary database, for example, Oracle, the storage engine and the query engine are locked. So you have to query the data with a proprietary or maybe or with a precise way that is locked with the way you store the data in the big data world, and particularly in Hadoop. They tend to lose coupling, to disjoint these two features, because there are many storage engines, for example, HDFS, we just mentioned, HBase, and different query engines like Hive, Impala, Spark, and so on. So, what is Jupyter? Jupyter is an interactive computing tool. And it all started with Python. And well, Jupyter, in its name, comes from the three languages it originally supported, that are Julia, Python, and R, programming language. But it nowadays it supports a lot of different languages, a lot more than 20, 30. And it all started with Python and interactive. So with Python, you have the Python shell, in which you can write programs line by line and see the results by yourself. With interactive Python, they gave you the ability to print images in the shell, or to interact with data with some kind of widgets and so on. So they then found these IPython notebooks. So you have a Word like Microsoft Word like page in which there are different cells, and in each cells there could be text, there could be images, and later they or even programs in these cells, and later they name these IPython notebooks as Jupyter Notebook. And here was the project started. So as you can see, there is a title, there is text, there is a mathematical equation of Lorentz system. Shout out to my mathematician's friend out there. And there is a program with which you can interact with. So Jupyter Lab is, I'll just mention it because, okay, so here's the Jupyter Notebook, and here's Jupyter Lab, that is just a different front end for the Jupyter Notebook. And as you can see here, there are many different Jupyter kernel you can access on. And a kernel is just a wrapper around a Python kernel or a Python environment. So all the kernels are separated and isolated one by another. Jupyter Hub, instead, all the products we mentioned were meant for a single user at a time. What if we want something more? What if we want to share notebook across people, across users, and gain the benefits from this kind of paradigm? So Jupyter Hub started as a tool intended for multiple users. So you can install Jupyter Hub on a machine, on a cluster, on a Kubernetes cluster, and people can work isolated by each other, and but still share notebooks inside this Jupyter Hub. So it's an extremely powerful and versatile tool. So the Jupyter project became extremely popular among data scientists because it had the access to data and explore data in a way that was basically never seen before. Another interactive tool that was similar but not as close to this kind of usability was, for example, Mathematica from Wolfram Alpha, but that was proprietary software. Everything I mentioned until now, it is open source software. So software developed by the community and released publicly. So it's very different from proprietary software where it's just a black box and no one can see inside. So we have talked about the world of big data. We've seen what is Jupyter, how we can use Jupyter, but in the context of data engineering. So here we are with the title of this presentation is the Jupyter parenthesis and the evolution, because we evolved progressively our approach in our data engineering team with Jupyter. So the first step was well, the first two steps were with one user, one machine. So we just had a general purpose virtual machine inside our center, in which there were installed the Jupyter notebook. And we, as data engineers, have to do lots of work, for example, in which we have to write with the command line, we use program with a command line interface. We often have problems because the documentation sometimes is lacking or we can find it. And but with Jupyter Notebook, for example, you can communicate directly with a terminal because the site could be talking directly with the terminal, and you can document the process with the text cells. So we already have some huge advantages. We could automate because you can chain child execution one by another. You can document and see perfectly and see the results of what you do. The execution environment is specific, and so you know perfectly where you are and what are you computing. And the user experience by people who work with this kind of interface is much better. So even this first step was completely change of paradigm respect of before. So the second step was installing the Jupyter Notebook in a Hadoop client virtual machine. So the Hadoop I mentioned before is an extremely powerful tool, but it's not as easy as you can think to work with, because the interfaces sometimes are confusing, or for example, it's not extremely user-friendly. Let's say like this. So by installing the Jupyter Notebook on a Hadoop client virtual machine, we could do all the work we did before, but in a better way. So we could, for example, use the Jupyter Notebook to be the interface for Spark applications. So we could, for example, see the initialization of a program, access to the database. We can see data. I can explore new data that comes from different sources and see the results in HTML on a web page. And that's a huge advantage when you work with this kind of platforms. So the user experience was definitely better. I'm going to show you. And here's a case study. Zapdos is a program I wrote last year, and it all was based with a user interface with a Jupyter Notebook. So you could check jobs, you could check whatever was done, and you could explore the results of the data and see graphs directly from the Jupyter Notebook installed on a Hadoop client. So it was a program of a performance log processing platform, and we have made different functions. For example, here you can see the function print data frame, because and I wrote a HTML wraparound of a Spark data frame. That frame is like an Excel or a table, if you're more familiar. And we've seen cool results because, for example, when before it took 6 hours or a day to recover from failed jobs. With this kind of tools, we just have to fill a form. For example, when you have to when you have to work with the public administration, but it was well, it was more user friendly than one. Okay, so all these were cool results, but we still weren't satisfied because we had to access to this kind of notebooks one by one. So we couldn't work together on a notebook, and we couldn't share we couldn't share what we did on those notebooks. So we evolved our party, the way we work with a multi-user environment, but still on one machine. So we installed Jupyter Hub on a general purpose virtual machine. So you can see here there are Anaconda for the kernel, the Python kernel environment management, and it was completely completely different approach because before it was an Amazon tool for one person, but building an Amazon tool for a team so they can work together. And you know, teamwork is overpowered. When you can work together, communicate better, and with your team is extremely satisfying, and you are focused on the results. And so we connected the Jupyter Hub interface with the LDAP and Active Directory authentication of the company. So there are many different internal products of this company I've been working for, but all are using this Active Directory in Microsoft for authentication. And Jupyter Hub is transparent on that. It doesn't add some useless layer of authentication. You don't have other passwords to remember and so on. It directly connects to the authentication system that everyone who uses every day. So it's really linear in this process. So you can share your notebooks, as I said before, and work together. The prototyping is much faster. So what is prototyping? When you have to do a job, we often need a minimum valuable product. So we need to collect ideas and work together, and then to build a script that not very sophisticated. We just need something that does a little of the jobs, and then we can expand it, extend it, and make it better. And this kind of process, so from the beginning to this prototype, it's very often is very difficult. It's slow because you don't know how to start. You have a blank page and you don't know what to write. When sharing notebooks, and you can literally vomit your ideas on these notebooks, and they literally just work. And then you can transform them in scripts. So they are extremely powerful. So another cool thing we did with Jupyter Hub was the interactive Python kernel management. So for example, with Jupyter Hub, only the data engineering team had access to this tool. Later, other teams asked to get access to this tool, so they could see data by themselves, so they could do some kind of computing. And what if, for example, there is a Python kernel, so a virtual environment of Python isolated by others, and maybe you don't want it to show to other people, or maybe you don't want other people to install other libraries on this kind of Python environment. With the approach we used, you can safely hide or protect your environment using the operative system protection tools. So you can grant the Python kernel to a user or to a group of users, and you can let read, write, or execute permission as readily as you want. So it is a very you can fine tune it with the permission very much. So it's even in from this from the security point of view, it's a real win. But all of this is outside of the Hadoop cluster. So how we managed to connect this Jupyter Run that was installed on a general purpose virtual machine to the Hadoop cluster I've been talking about before. Installed a Jupyter Run inside completely the Hadoop cluster wasn't viable because from the security point of view, it's not a good practice to install completely and let everyone access to this kind of power, because when you access to the Hadoop cluster, it's you already should ask a couple of questions to yourself. So, well, here we can see the granular Python access permission. We connect the Jupyter cluster to the Hadoop cluster with the Jupyter Enterprise Gateway. So we managed to connect it with this tool that was developed by IBM, and it lets you connect with a layer of permission to the Hadoop cluster. And instead of using the kernels installed on Jupyter Run, you can use the kernel installed on the Hadoop cluster, so you can start Spark directly from the notebook, and you can work on that notebook, share it with someone other, and you can work on the Hadoop cluster as were moments ago. So this kind of step forward was huge, because you could manage multiple clusters at a time. We could see what was in the cluster. So Jupyter Hub became our first mechanism of debugging and see and explore data that was in the cluster. So this is extremely cool. This I call it the ultimate collaboration tool for data scientists and data engineers. So here's what we did on the cluster, and this is a work in progress, prospect on the future. And this is okay. While all of the previous attempts were still one machine, with working on one machine, this means that they are not high available. So if one machine, that particular machine, goes down, you're in a bad situation because it doesn't work anymore. You can do a step forward with a paradigm that lets you have Jupyter Run on multiple machines. So I don't know if you're familiar with Docker and Kubernetes, but these two technologies are technologies that are about the containment of application. So instead of delivering some source code, you also deliver the system around the operating system and what is installed on that operating system with the source code. So the containerization is about that. And they successfully containerized Jupyter Run and on Kubernetes, that is an orchestrator for Docker. So having Jupyter Run installed on Kubernetes means that is high available, because a Kubernetes cluster can be installed on multiple nodes that are single machines. There is a pod, you can manage the pod in which is spawned the Jupyter. So for example, in the case we mentioned it before, what if a user needs some particular binary installed, or something that is just something more than a Python library? It couldn't install it or have it in an easy way. But if you have a Jupyter Run installed on a Kubernetes cluster, it's much better, because you can manage the image, so the operating system in which the pod spawns. So it's a huge step for this one. And having different users, anyone in different pods that are the minimum unit inside the Kubernetes cluster. It means that they cannot tamper or intervene or create problems one by another. So it is a much better solution. And you can also manage the CPU and the RAM that any user has. So it is you have a much better management with this approach. So let's talk about security, because this is an important thing when you talk about this introducing new technologies on enterprise environments. From the security, there are different enterprise challenges, because you want to avoid unauthorized access to data. So the right people need to work with data, and wrong people need to didn't know they exist. You must be compliant to the rules of your company, and depending on the country you live in. So, for example, if some data must be logged or someone access to it, you must be careful about that. And you not only have to know when problems occur, but you must to proactively prevent the problem. You can't just let it happen. So we managed to use different technologies to prevent this kind of problems. And for example, when we installed Jupyter before, in this kind of setup, we managed to use the HTTPS certificate to secure the connection. So we were lucky, because the company we were working for are also certificate authority. So they were they could send us very easily a certificate to protect our internal product. And if someone managed to intercept the data, they couldn't see what was inside, because it was encrypted. So that approach was extremely useful. Then another rule we used was the network firewall. So, for example, if we have this kind of application, we were working with the networking team to open the least number of ports that the application needed, and nothing else. Because when you work with the enterprise data, you need to make sure that nothing is too open, and nothing can access to other machines. Because even if you protect a machine or an application with a password, for example, but multiple machines can access to can see it, you could, for example, do a brute force attempt to break down the password, and that's not a good thing when you work with enterprise software. The use of federated identity, the Microsoft Active Directory with the LDAP, that was a cool enterprise solution, because instead of forcing user to memorize more and more passwords, they could just access to the ones they knew before. So it's easier to secure software. And the fact, last but not least, we added another security layer, because instead of letting people access directly to that platform, we worked with a networking team to access to that platform by a bridge machine. So first you have to connect remotely the remote desktop connection to that machine, in which everything is logged and controlled, and then you could connect to the Jupyter Hub of production. So these were all solutions we put on, because we wanted to make sure that the cluster was safe. So thanks for seeing my speech. And if you have any question or anything, you can write them on the chat. And if you want, or we can have in next hour a one-on-one meeting. So if you want to ask them some specific question of our setup, my name is Luca Soato, and thanks for helping us. Bye bye.